So one thing with complex event processing is the scalability challenges. Anytime when you talk about scalability, it's like, what are you trying to scale, right? The very first step is the tuning, the optimization. Are you optimizing for speed or are you optimizing for throughput? These are two opposite ends of spectrum. Now, if in the case of CEP, we are always optimizing for throughput. And throughput is a function of how many events can you process in CEP system, right? That's one aspect. The second aspect is, what is the workload to process this event? Because somebody can come and tell, I'm processing 1 million events per second in my system. But what are those events? What are you doing with those events? If you're just passing them through, you can process probably 100 million events per second. But if you start doing queries or start doing analysis on those events, then you might not be able to process 100 million events, right? So the idea is, the larger the workload is, the lower the throughput is going to be. So in terms of volume, there are well-known strategies out there in the industry that you can leverage. You can equally distribute the load across your cluster. This works very well for stateless architecture, share nothing architecture, where all the nodes are equal. They can perform, they can process a request, any request at any given time. They don't maintain any state. You don't maintain state on the node itself. The state is maintained somewhere else. Actually, even this is another key point. Anytime we talk about stateless architecture, actually, matter of fact is the state is always required. It's just that the compute nodes don't maintain the state. State is maintained somewhere else. If it's maintained database, the database might become bottleneck. So mainly you leverage cache, in-memory caches for this. Anyway, another way to handle volume could be sharding your workload by key hashing. This works really well for stateful processing, but the caveat here is, let's take an example. If you're sharding your workload by users, and one of the users happen to be a merchant, and the merchant will have much higher volume than individual users, right? In this case, one of the nodes in your cluster will become very hot. It will be taking lots of load, right? So that's the caveat with sharding-based technique. So really, you have to know your workload, you have to know your data, you have to know your customers' interactions to pick the right strategy for yourself. So actually, event volume scaling is not a problem. The main problem, the challenge that comes with the CEP technology is, how do you scale the event processing load? And I don't want this talk to become too much of a CEP centric. I just wanted to give you a flavor of why CEP scalability is complex. So I'll just very quickly walk you through this example, and then we'll focus more on big data. So one strategy you can take is that you can divide up your workload into units, separate units. And I view this as reversing your MapReduce job on Hadoop. So basically, and we'll talk more about that, how you reverse the MapReduce job. The idea is that if you can divide up your workload into smaller units and assign those work units to different processor nodes, means that you want to, instead of doing the whole workload on one node, you can say, I will have a tiered architecture. Let's take an example. If I can split this workload into 3 different units, then I want to have a front-end machines which takes care of first unit of work, then hand over the next unit of work to second-tier nodes and third-tier nodes and so forth, right? Generally, what you do is you try to do filtering on the data, because in CEP systems, you don't always analyze every single event coming in. So it's not always applicable to certain all the aggregations. So there are different type of aggregation that you're doing by events, and those are done by filtering the events, right? And then, so the idea is to divide the workload work units into stateless work units and stateful work units. Stateful work units are where you do complex logic processing. And let me give you a concrete example, that way it becomes more clear. Let's say we built a hypothesis that whenever my customers use mobile phones, we believe our customers use mobile phones during non-working hours. Then if that's the case, then my business policy, I want to have a business policy that when user is on a mobile phone and if they're in non-working hours, that's the point when I'm going to offer them coupons, either for restaurants or to go to movies and so forth. So in this case, what I really need to know is when does the mobile logins exceed the web logins, right? So I have already I can already divide up my workload now, right? So this is what I was talking about, reversing the map reduce job. So you do filtering first. Is this a mobile event or web event? If it's a mobile event, then give it to mobile velocity processors. If otherwise to web velocity processor. Velocity processor is nothing but that can keep account how many logins are happening in a certain amount of time. Then based on if the logins exceed certain threshold, then you can give it to your business rules processor. So that's just one example of how you can scale CEP system. There's many